we go. All right, so this guy's going to be plus. That's better. Okay, so then what that tells us is this thing is going to equal 0 when x equals 9, because 9 minus 9 is 0, or when x equals -7. Okay. So that's the places where it crosses the axis, but they're asking us for the vertex. Now the vertex in this case, since this is a positive x squared, you're going to get this. You're going to get this, right? All right, so what we've got here is we've got two places where this thing crosses the x-axis. So let's pop an x-axis in here real quick. Okay, so something like this. Okay. Now, what this is telling us is here at -7 we cross, and here at +9 we cross. Okay. So we could put this thing into vertex form, but honestly, that's kind of a pain. Okay, that's a pain in the ass, Mentilp. Let's just put it on the table. Okay, so here's a neat little hack for you. Remember that parabolas, these x squared graphs, are extremely symmetrical. Okay, so what that tells us is that where this thing bottoms out, which is what the vertex is going to be this guy here where it bottoms out. Okay, so where that bottoms out is going to be halfway between these 2 points. Okay, so how do we figure out that point? How do we figure out that midpoint? Remember, the midpoint means just average the 2 numbers we've got. So that's basically saying this. We're going to do 9 minus 7, and since there's 2 numbers, we divide by 2. Okay, and the sign counts. So you say 9 minus 7, that's going to be 2, and then over 2, so 2 over 2 is just 1. So what that's telling us is this thing bottoms out at x equals 1. Not a fantastic drawing, but at least it's on the positive side, right? Okay, so then to figure out the vertex, what you do is you say, okay, we just figured out that the x value is going to be 1. So our vertex starts with x equals 1. Okay, so the way we figure out the y value is we just plug 1 in here every place we see x. Okay, so then we say, okay, 1 times 1, that's 1 squared, right? Still 1. Minus 2 times 1, so minus 2 times 1 is minus 2. And then we got minus 63. Whoa. So we add these guys together. So I've got minus 63 and minus 2 more is minus 65. Plus 1 moves us back up to minus 64. So our second value is minus 64. Okay. It says then graph. Okay, well, we've kind of graphed already, but our graph is a little bit off because obviously this probably is not negative 64, right? So it'd be more like this. So we'd have a graph come way down here someplace. We'll call this minus 64. And then this would be 1. So that's way down here. And then you come up like this. You come up like this. And this is going to be 9. And this is going to be 7 right here. Okay. So that's good enough as far as the graph. You know, I'm more interested in, can you tell me where these points are? But like I said, the vertex, if you need to figure out vertex form of this, which we'll probably be doing this down the road, But you'd have to do something called completing the square, which we haven't talked about yet. So it was kind of weird that they brought up the vertex at this point. But like I said, there is an easy hack for that. If you figure out where it crosses the x-axis, like we did here, at -7 and +9, then the point halfway in between is 9 minus 7 divided by 2, 2 over 2, which is just 1. So then your first point of the vertex is 1. To figure out the y value, we just plug back in here for 1. And here's another good hack. When you're just plugging in 1, you just add the coefficients if you're plugging in 1, which we were in this case. So this guy's technically 1, so you got 1 minus 2 minus 63. That looks familiar, right? So that's a nice little hack. If they want you to put in x equals 1, you just add up the coefficients or the numbers in front of each term. So 1 minus 2 minus 63 is minus 64. Boom. Perfect. Okay. Questions? Okay, Chloe's good. The rest of you okay? I know this is the heck of a thing to wake up to, right? All right, let's continue on. So the next one's pretty much second verse, same as the first. Okay, so this one, same deal. We'll go ahead and do our diamond thing. So our top number this time is a positive 63, and our bottom number is 16. Okay. So since everybody's positive, then the two numbers we're looking for are also going to be positive. So this time we need numbers that multiply together and give us 63 and add together and give us 16. And they're both going to be positive. So this looks an awful lot like the last one, doesn't it? Except we've got a positive sign here, and instead of a -2, we got positive 16. So what's going to happen here? Yeah, we're going to use that 9 and that 7 again, except this time one of them's not negative, right? Perfect. So 9 times 7, 63. 9 plus 7, 16. Bam. That was easy. Cool. All right. So we go ahead and say, okay, let's set this up as a factor. All right. So then we've got x plus 9 and x plus 7. Fabulous. All right, so the places where this thing is going to cross the x-axis, really.
Mrs. Jones, would you please report to the media center? Mrs. Jones, thank you.
Yeah, Jones, get your butt over there. Anyway, so again, we know that basically what we say is these are two numbers, right? This is a number and this is a number. And we want to know when you multiply these two numbers together, what makes them equal 0? Well, if you multiply two numbers together, that means at least one of them has to be 0, because 0 times anything is going to be 0, right? So then again, you just pretty much switch the signs on these. So you say at x equals -9, because 9 minus 9 is 0, right? Or x equals -7, because 7 minus 7 also 0, right? Cool. Okay, so then this is the same deal as we had last time. So we're going to have some kind of graph, right? And this one is going to be at -9. All right, this thing will write. That would be nice. So we're going to have one at -9, and we're going to have one at -7. So these guys are kind of close together. Okay, so -9 here. Come on. And -7. All right, not -1, -7. There we go. Okay, so then this is going to look like this, right? It's going to come down here. It's going to drop down someplace, and it's going to come back up. Okay. So now they asked us for that vertex. So they asked us for the same thing again. Okay. So we need to figure out this point here. So we just got done saying on the last one that the vertex, the first point on the vertex, or the x value of the vertex, come on, is halfway between -9 and -7. So what number is between -9 and -7? We can do this mathematically, but you might be able to tell what this one is just by looking. Any ideas? No, it's not. So remember what we said last time. They said we would take the midpoint, which is the average of the two values we have. So I take -9 plus a -7, so it's -9 minus -7 divided by 2. So -9 and -7 is -16 divided by 2 is -8. And that should make sense because halfway between -7 and -9 is -8, right? Since those guys are close together, we don't necessarily have to do the math once you get the vibe for it. Okay, so that makes this guy -8. Okay. Then to figure out the other guy, we're going to plug -8 in here and in here. So this might require a calculator. Well, -8 times -8 is positive 64, right? So we know that much. So we get 64. Then we've got 16 times -8. Okay, that one sounds like a calculator thing. So where's our calculator? We haven't had him out in a while. Gotta go find him. All right, there he is. Let's bring him into the scene here. All right, make him a little smaller. That would be nice. So we can see what's going on. Move you over here. Bring you up, down a little bit. Okay, there we go. All right. So then we said the second guy here is going to be -8 times 16. So that's -128. So it's 64 minus 128, and then plus 63. All right, that sounds like calculator city again. So we got the -128, we go plus 64, plus 63. Right. So that's just -1. Okay, cool. So these guys all add up to -1, which means this guy here is -1. Okay, and that's a pretty good graph for what we need here. So we know that the guy crosses here at -9 and -7 and bottoms out here at -8 and -1. So that's this point right there. Okay, so that's a pretty good graph for what we need. Okay, see how that works? So we factor to figure out where the thing crosses the x-axis, right? X-axis right there. Then we can average those two numbers, add them together and divide by 2, to figure out the first point of the vertex, and then to figure out the second point of the vertex, we just plug that first number in to the original function and figure out what y is. And that's it. Questions? I know, more fun than you thought humans were allowed. All right, so let's continue on. All right, so it says, write the factored form for the quadratic function. This is wicked easy, by the way. So first thing you ask yourself is, say, self, where does this thing cross the x-axis? What 2 points for x is where's this thing crosses at? So it looks like we cross here. We cross here. So what are those two x values? So minus 4 and 3. Perfect. So I write that down over here. So I got minus 4 and 3. Now they want the factored form. That's that thing where we got like the two sets of parentheses. So let's do this. All right. And then what we want to do then, switch the signs on these guys. So he becomes plus, he becomes minus, stick a couple x's in here, and we're done. That's it. Because now if you take this value here, negative 4, and plug him in here, minus 4 and plus 4 is 0. Anything times 0 is 0. So we're sitting right here. Cool. And then same thing over here. If you plug in 3 right here, 3 minus 3 is 0. So that's another place where we're going to be on the x-axis, or y equals 0. Because remember, this is y equals, or f of x if they want to get fancy. That's it. So if they ask you for the factored form, they give you a graph, it's actually pretty easy. You find the 2 points where you cross, write them down, switch the sign, stick some x's in front of them, and you're done. Done. Easy, easy. Questions on that one? Okay, easy and peasy. All right, so let's go ahead. Got a couple what we'll call standardized test type questions here, and that'll wrap it up for this section. All right, so it says select all equations you can solve easily by factoring. So what do we think? How about A? Can we solve that pretty easily? Yeah, it's not bad. Because all you do is you'd bring this guy over, make him plus, and that's something that'll factor pretty easy. So yeah, that one's okay. Now, how about this guy? So C's another one that's easy? Yeah, I agree. So the other guys, they might factor, they might not, but they're not as easy as these two. So my guess is that's all they're looking for, is the fact that these start with an x squared. Can we factor this guy? I don't know. Let's give it a quick try. So we go x squared and then plus x. And then we have to bring the 5 over, so he becomes negative 5 equals 0. All right, so the problem with this one is you're going to do 2x in one of them, right? X in the other one. So we've got a minus 5, so it means one's going to be plus, one's going to be minus. And they have to add together to give us 5, right? Or I mean multiply together to give us 5. So let's try this. Let's try a 5 here and a 1 here. Okay. So if we do that, then since this guy's positive, let's put the plus here and the minus here. Now, if we could get the middle guys to match up to give us just positive x, we're good to go, right? So I do 5 times x, that's 5x. Then I do 2 times negative 1, that's negative 2x, right? So that gives me 3x. We needed just plus x. So is this guy factor easy? I'm going to vote no. So I think that's our answer. I think it's just A and C. but just to kind of show you. All right. And these other two guys, they might factor, they might not, because this guy definitely did not factor. But the point is, it's not that easy, right? So they said easily. It's like, yeah, A and C. I think we're cool there. All right, nice. All right, so let's go ahead and check out our SAT problem. So it says a quadratic function of the form x plus b squared plus c equals 0 has a solution of -2. So it says its related function has a vertex at 2.5 and minus 20.25. What is the other solution to the equation? Whoa. Okay. So here's the deal. This is that bit where we were talking about, I don't really care about this. I'm kind of worried about these guys. Okay. So what you want to look for, no. All right, so here's what we need. Think about it this way. So we've got some number. We need to find our solution, right? If we do the average thing, right? So we say x minus 2 divided by 2 has to equal 2.5. Okay? So what that means is when we look at this guy, remember we said you have a graph like this, right? So they've told us that this guy crosses at minus 2 and bottoms out at positive 2.5, right? So they want to know what this other value is. So remember before, we had the two values. We had this guy, and we just averaged them, right? Add them together, divide by 2. So that's what I'm doing here. I'm taking the guy I don't know, we're going to call him x for right now, and added him to the -2. So x minus 2 divided by 2 has to equal this average, which is 2.5. Pretty sneaky. Yeah, this would probably be one of the tougher SAT questions. Gotta be honest. All right, so here's what we do. Here's an interesting hack. What we're going to do is we're going to multiply both sides by 2. But something I kind of discovered on my own through the years, and this is a handy little thing, that over here I've got a 2 on the bottom of a fraction, right? If I want to move him to the other side, all I have to do is cross him off here and bring him upstairs over here, which is technically the same as multiplying both sides by 2. Because if I multiply both sides by 2, this 2 would cancel out, and then I have to multiply by 2 over here. So now I'm going to have x minus 2, and then we do 2.5 times 2, so 250 times 2, that's $5, right? So that's just 5. And the last thing we do is we go ahead and add 2 to both sides. So x equals 7. Bam. So that was asking you something you already knew how to do, but they were asking you to find a piece of the puzzle that they normally give us. So that was a little tricky, not gonna lie. You follow me on that one? Not really? Okay, so again, think of it this way. If we had this thing, remember the last problem we were doing? And they told us, okay, well, this is 7, and this is minus 2. Then we would do 7 minus 2 divided by 2. 7 minus 2 is 5 divided by 2. 5 divided by 2 is 2.5. So instead of doing the average, we didn't have this guy here. So that's why I called him x. And then minus 2, that's the same. Divided by 2, that's the same. That was right here before I crossed him off. Okay, and then that would equal 2.5. So just kind of shifting the numbers around. Okay, and like I said, that's probably one of the harder SAT questions you'd see. Actually, it's probably an ACT question since there's 5 answers. ACT has 5 answer choices and SAT has 4. So, all right. Well, like I said, don't get all worried about that. I'm not giving you tests on this kind of stuff. This is just showing you like ACT stuff. Most of you guys are what, 9th graders? So you don't have to worry about that for a couple years yet. But if we start kind of presenting this stuff to you now, then when you get there, you're like, okay, yeah, I've kind of seen stuff like this already. Cool. All right. Okay, so that wraps that one up. We got a couple minutes. Let's just do a quick intro to what's coming up next, and then we'll really get into it tomorrow. Let me pop this up here. So this is going to be section 9.3. And the reason we're going to be doing this is, remember I said about taking and completing the square and stuff like that? Well, we're going to have to work with some square root stuff. Okay? So let's mess with this for a couple minutes, and like I said, then we'll really get into it next time. All right, so what do they mean by rewriting radical expressions? I know, great. All right. So here's the thing. You've probably heard me say this a few times already. Everybody hates fractions and square roots, so we try to make them as small as possible. Okay. That's my own line. I came up with that. I didn't hear it anyplace else. So here's what we got. So it says compare each pair of radical expressions. All right. So this definitely looks like it's something for a calculator. Okay. So let's check it out. So the first guy here, we have, let's clear this out. And I forget if I have to hit the square root button first or second. I think I hit it second. So if I do 3 and then square root, so I get like 1.73 roughly, and I take that times 6. So it's like 10.4 roughly. Okay. So our other guy is a square root of 108. Let's see if I can move him over just enough that we can see that. Yeah, there it is. I knew it wouldn't work. Okay, close enough. So it's square root of 108. So what we do is we'll take the square root of 108, see if we get about 10.39 again. All right, so then we go clear. We say 108 and square root. 10.39. So these two guys are the same. Interesting. Okay, so let's check out some of these other guys. So next one says 2 times the square root of 21. So on this calculator, you're better off if you're using the calculator on your computer. So we say, okay, we'll do 21, take the square root, so 4.58, blah, 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 and then times 2. So he's about 9.16. So next guy, what is he? I can't read it. Hang on, I'm going to move him over here. Okay, so he's 4 square root of 5. Okay, so let's try that. So again, same deal. We go 5 square root it. Get that guy, and then we take that times 4. So 8.94. So those two guys are not the same. Okay. So let's take a look at the last guy. So we'll clear him out. This is 40 square root 6.32, and then times 42. 265.63. Okay. So whoops. So let's take a look at the other guy here. Over, there we go. So the other guy is 40 times the square root of 42. And we'll know if that's the same. Let's check it out. So we do 42 square rooted 6.4, and then times 40. 2.59. This last guy was 2.65, right? Or not, just 265, my bad. And and the other guy's 259. So yeah, these two don't match up either. So only the first guy matches up. All right. Let's talk about him for a second. So we went through here and we compared these guys. We said, okay, these two guys aren't the same. These two guys aren't the same, but these two guys are equal. Interesting. Question is, why are they equal? So what it's telling you is this can be, let's just do our bunny ear quotes here, could be reduced, quote unquote, to become this. And this is what the math guys like, because they like this number here underneath the square root to be pretty small. It's like reducing fractions in a way. They don't like big fractions, right? They don't like big numbers on the square roots either. Okay? So that's where we're at. Well, how did they do this? Okay, well, what they do is they take the perfect squares and see if you can pull a perfect square out of 108. All right. So how do we do that? Well, there's a bunch of different ways to do that. Okay. So first thing we look at here is we say, all right, we could do a factorization of this. So what we do here is we say, okay, let's start with 108. And he's an even number. If he's an even number, what can I divide by? Any even number can be divided by what? Excellent. Nice, Chloe. So I divide by 2. So again, if you need your calculator, that's fine. Break him out. So we say, okay, we're going to start with 108. And we're going to divide by 2. That's 54. All right. 54, also an even number. That means I could divide by 2 again, right? So if I divide him by 2, let's do it again. So we say 54 divided by 2 is 27. Okay. Now, not an even number anymore, is it? So instead of trying 2, because we know that's not going to work, we'll bump it up 1. We'll go to 3. Okay. So let's do that. So 27 divided by 3, most of you probably know this already, but just in case, that's 9. So 27 and 9, and then that'll be 3 times 3. Okay, so why do we do this stuff? Well, here's how this works. This is now the same, so the square root of 108, and I'm going to show you a couple different ways to do this. So the square root of 108 is the same as saying the square root of 2 times 2 times 3 times 3 times 3. So like I said, there's different ways of thinking about this. Whatever works for you is cool, okay? So here's the rule as far as doing it this way. We've turned it all into what they call prime factors. So these are numbers that we can't divide any further. The only way you multiply two numbers together and get 2 is 1 times 2. Same thing with 3 is 1 times 3, okay? So here's what we're going to do. We're going to look at this and say, all right, so I'm underneath the square root, so we'll call that the house. So all these numbers are inside the house. Okay, so the only way they can leave the house is in pairs. I got a pair of 2s. So that means a 2 comes outside the house. I got a pair of 3s. That means a 3 comes outside the house. And I've got 1 extra 3. He can't come out because he's not in pairs. He stays here. Okay? So then 2 times 3, we can multiply them together, right? That's going to be 6 square root of 3. I know, that's a little bit of a mind blower the first time you see it. I get that. Okay, so that's one way. So let's talk about another way. I'm just going to bring up an extra screen here that we can write on. All right, so I'm going to start with the square root of 108. All right, another way to do this is think about what are our perfect squares. So 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49, and so on. But this will be enough to do what we need to do here. All right. So the first question is, can I divide 108 by 4? Well, let's find out. So clear it out. So 108 divided by 4. Oops, I put in 8. My bad. Hang on. 108 divided by 4. There we go. 27. Okay, so that divides. Now, that's still a pretty big number, so we probably go down. Oh, is it time to go already? Okay, we'll wrap this up real quick then. So let's try 108 divided by 9. That's 12. So 4 goes in there, 9 goes in there, so chances are pretty good 36 goes in there. So you could rewrite this, and like I said, we'll go over this next time, as the square root of 36 times the square root of 3, which is 6 square root of 3. But we'll do this next time. I didn't realize we're so close to being done. All right, guys, appreciate you showing up today, and let's get to your next class. See ya.